And the solution is wrong. Shit. These workers are too loud. This company allowed them to talk. Why? I might need to silence them forever. I already see some convenient holes I could throw the people into instead of talking. We are supposed to count how many zeros, ones, twos, threes, fours and fives there are in this room and write the results on these cubes at the bottom. No idea why the holes are there. So first off, they probably want to talk among themselves. So let's just, get rid of all that noise. So everyone, please leave the room. Thank you. Blessed silence. Oh wait, this manager is still here. I forgot. He actually turned into a poet. I was driving on a road and I thought, hey, why don't I download? If only I had slowed. As for the download, I got an error code. What an excellent poetry. I would like to throw him down the hole as well. Anyway, the coding assignment. I would say these people should tell one another which numbers they're gonna be counting. And then we're gonna have to do a stupid grid search and write the results. So everyone should probably store the nearest data cube in their memory. It's hopefully gonna be the ones on the bottom row. Let's just make sure they are by picking them up. Yeah, okay. So these are the nearest data cubes. Now, if to the left of you there is a worker, so that's those 5 people, you're gonna be listening for probably high, and otherwise, that's the first lady, you set in memory 2 the number you're gonna be counting. That's gonna be a 0. Then you tell hi to the person to the right, and she's gonna look. Let's make her look at your number, so she'll know you're counting 0. So let's do it like this. Everyone set 0. This person tells you hi. So what you're gonna do is calculate in memory 2 their cube plus 1, and then you have to pick up the cube and write that number. And I think this needs to happen here. So you calculate, trigger the next person. No, you need to trigger them after that. So you pick up the nearest data cube, write whatever number you have in memory 2, and tell hi and drop the cube. So now we should have 0 all the way to 5 on these cubes. So first 0. Oh, and she told hi to the non-existent person there. So you're supposed to say hi there, top right. Write 0, say hi, drop the cube. You calculate 1, 2, 3, 4, 5. Great. So far it works. They now should know which numbers they're actually supposed to count. So in memory 2 they know what they're counting. And I would like to know whether their level stops once they have placed down those cubes. So if this is the way to go. So let's say if above you there isn't a hole, you step up and keep doing that. That's just a dumb piece of code that's gonna make them keep doing something. Okay, so the good thing is that it's still running. The bad thing is that I messed up. If above you there isn't a hole. Oh, step down. I wanted them to step up. Well, never mind. Now we need to do a grid search and count the numbers in these cubes. So I would say they should walk all the way left and then go up, count the numbers, right, count the numbers, right, then perhaps up, down, count the numbers, and so on. That's gonna be easier to code. And I don't really think we're gonna complete the size challenge here. What are the optional challenges? Oh, 24 commands! We might be able to do it. That's quite a lot, to be honest. So let's say if to the left of you there isn't a wall, keep stepping left. Once you've done that, we're gonna say if above you there isn't a wall, you're gonna keep stepping up. And again, keep doing that. Once they've reached this wall, they should keep stepping down, right? No, not right, down. And count the numbers. Well, we could just say take a step to the right after you've done that. And then, if under you there isn't yet a wall, you're gonna calculate in probably memory 3. Oh, and you're gonna look, sorry, there isn't a wall, so if you are standing on a data cube, calculate, memory 3 is gonna be your result. What's memory 1? Oh, that's the nearest data cube, so we need that. You're gonna calculate memory 3 plus 1. And not just any data cube, but the data cube, the value of the data cube, must be the same as memory 2, which is the number you're counting. So if the person is counting 2s, they need to find a data cube, and the data cube must be a 2 for it to count. Then you step down and repeat all this. And once they reach the wall here, they're no longer gonna enter this if statement, so they won't count these cubes as well. Oh, and once they've reached the wall, they're gonna make a step right and then start going up again. Yeah, that's it. So reach the wall and go up again, step right, go down, and count the cubes again. Great. And now we need to break from this infinite loop. So they're gonna step right here, and the last time they're gonna step right is this position. They step right and they can already stop. So once they've stepped right, they should check if to the right of you there is a wall. You just pick up the cube you've stored in memory 1, that's your starting cube, and you write memory 3, which is the result, how many cubes of that number you found. Then you drop the cube and you should be done. And I think I've messed up this jump here. They're supposed to do this forever, right? So if under you there isn't a wall, so if there is a wall, they jump here and go back up, and another jump needed here. So once they've reached the wall, sorry, before they reach the wall, they should just keep doing this. That's a really tough code to write. We've got 26 commands and we only need 24 for the challenge, so we're not far off, I would say. Let's see whether this works. So the first bit we know works. Now they are gonna write their numbers there. This lady is already on her way, and now she's gonna count the numbers when going down. And you can see that the people are already counting. So just bubble through all that, keep counting, speed this up. This is really slow. We could do some pieces of optimization, but this is basically gonna have to happen. Now this is the last column. Now the lady is gonna go up, right, and now write the number that she's counted here. And I don't know what the correct answer is supposed to be. So 11 zeros we're probably gonna have. 2, 4, 5, 6, 7, 8, 9, 10, and I probably missed one somewhere. So hopefully that's right and I didn't mess it up. We might be off by 1. So no, it worked. Nice. 320 seconds. We need half. So it's supposed to be fairly slow. So we need to cut the time in half and we need 2 commands fewer. I mean, I'm not complaining. This code was pretty difficult. Love it. So I'm gonna do 2 things at the same time probably. I've copied the code into those 2 tabs. The first tab is gonna be the size challenge, so remove the 2 commands. The last one is gonna be speed challenge. And I've been looking through the code, and I think at the start, not much we can do. We might also go from the right, so this person writes a 5 immediately, and these 2 are not gonna be listening, but instead checking for those numbers. Something like that, you know. But here, I can see an optimization already. So once they reach this space, basically the left wall, they would start going up and then right and down again and count the numbers. So reach here, up, down, right, up, down. This column is basically wasted. So what if we skip it? Once you reach this wall and this if statement no longer triggers, you continue, you just step right. Not just right, but top right. That's also an optimization, because then they start going up in this column already. So that should already be faster. See, they skipped the column entirely. I don't know why I ran the code again, because I am not gonna sit here for 2 minutes to watch this. Anyway, I'm gonna let it run, but think a little more, because there's those 2 rows is also dead space. So we could say that once they reach a non-data cube thingy, they can already start going up. So they don't have to reach the wall here, but the non-data cube thing is enough. For some reason it no longer works. They just keep changing the numbers. I think that's because they don't end their program here. So once they write the result and drop the cube, they should also end their program. Because it seems that the last person is still counting, and this lady has already finished her second pass. So here they're gonna step right, and let's step up again as well. So they're now gonna be standing here. And here we can say, if above you, instead of there isn't a wall, there isn't a data cube. So above you, there is a data cube still, and they're gonna stop here, because here there is no more data cube. Then they're gonna step right, and I might need them to step top right, so that below them there is a wall still. No, you know what? Don't. Step right, and then when going down, you're not checking if below you there is a wall, but instead if you are not standing on a data cube. Sorry, if you are standing on a data cube. We don't need this if statement. If the data cube is the correct one, you calculate it, otherwise step down and keep doing this. Once they've reached basically this spot, when there is no longer a data cube, they jump to here and start going up. Alright, that should be a little faster. Okay, it no longer works. Oh, why doesn't it work? Oh, sorry, if above you there is a data cube, you step up. There. Yeah, working nicely. To make this faster, we basically need them to calculate when they're going up and when they're going down. So go up, step right, go down, step right, go up, and so on. And this is already wrong. Now, why is this wrong? I don't want to reset, I want to read it. We've got 10 zeros, allegedly. Okay, let me pause it and count the number of zeros before running it again. I see 9 zeros. And I think that this layout should be the same, so she's gonna write 10, meaning we've got a bug in our code. No, 9, that's correct? What do you mean? So we've messed it up somewhere. Oh, I think they're not counting the corners, maybe? Okay, why doesn't this work? It's supposed to be working. So again, let's count the zeros, because we've got zeros on the top row and on the bottom row. So there's 8 zeros. Now slow it down. Does she count this 0 here? Yeah, she does. Okay, and now the bottom one. And again, she counts the 0. So what's your problem? Yeah, we've got 8 zeros. What's your problem? Now let's see what the other people have written. I just need them to move a little so I can count it. So 6 ones. But we've got 7 ones. So that's 8 ones. That's wrong. Why did you count only 6? Oh, I think I know. Because using this optimization of skipping the first column, I make them go up, then right, and then start counting one going down. So they basically skip this column of numbers as well. So let's do the step up after they've counted. Again, see whether this works. This is the hardest part when optimizing something, is that you're gonna make a seemingly, innocent step in your logic, and that weird little innocent step that's supposed to speed something up actually messes up the whole code so that it no longer works. That is exactly why you write tests. So with good unit tests, you get to test your code so that this little shitty thing you do is caught in time. Now what we want to do is copy this calculating thing when we're going up. So if above you there is a data cube, you step up, meaning you're now standing on 1. So if the number you are standing on is the one you're supposed to be counting, you just increase your counter by 1 and keep doing that. After you've done that, meaning you're somewhere here in the top row, you step right, check for a wall, and then you start going down. But we need to take the step down first, because we've already calculated this cube. So step down first, then check for a data cube. I fear this might not work with zeros because here we step out of bounds. So I think here we should again say if below you there is a data cube, only then you step down. Standing on a data cube, calculate, step right. So they're gonna go up, down, up, down, up, down, up, down. So after they've gone down, they should check for a wall. So actually check for the wall here. That's when you're gonna encounter it. Otherwise they would have to go all the way back up, step right again, and then the wall. Now let's see, did I mess it up again? Or is this gonna be much, much faster? We technically should have cut the time in half, because they're now counting when going down as well as when going up. And the solution is wrong. Shit. So, again, calculate. How many zeros do we have? We have 15 zeros, I think. So let them count that, and then we'll check what they're actually writing. 14. So she missed a zero. Which zero did she miss? I see that there's one on the bottom row and on the rightmost row. So probably she might have missed this one, because otherwise she would be off by 2. So if below you there is a data cube, you step on it, and if it's the correct number, you calculate it. She shouldn't have missed that. 13 ones. Let's see how many ones we actually have here. Well, that's correct. We have 13 ones. What about twos? There are supposed to be 8 twos, the guy says. And he missed 2. He missed 2 twos. Oh boy, how did he manage that? Did I miscount the zeros? Yeah. There are 16 zeros. I've miscounted the zeros as well. So they are off by 2. At least these two are. Ones are correct. Zeros and twos are off by 2. So where do we have 2 zeros and 2 twos? Probably like the last row, the first row, columns, the corners I would be suspicious of. So the first column, 2 zeros and 2 twos. Sorry, 3 twos. Okay, so that shouldn't be the problem. This row, on the other hand, might. So let's see here. If above you there is a data cube, you step on it. Then you are standing on a data cube, so you calculate it. This means that you should get all the way on this row. And once you do, you step right. Oh, I see. You step right, but you're now standing on the data cube and you're gonna step down. So you're already standing on it, so you should first calculate and then step down. So when you're standing somewhere here, you look down. Is there a data cube? Yes. So calculate mine, step down, and repeat. Is below me a data cube? So you shouldn't do that. You should do, if I'm standing on a data cube, I calculate it and then step down. Yes, this is the way. Did I fix it? And is this fast enough? I'm just gonna trust. Yes! No! So we need to knock off 11 more seconds. But we're almost there. Now I wonder, would I be able to knock off those 11 seconds by optimizing the way they decide which numbers they're counting? So if to the right of you there isn't a worker, you pick up memory 1, the data cube, and write 5 on the cube. Then you jump to here and drop it. Maybe. The point is that they shouldn't be listening, and the other people should be looking for workers next to them as well. So also let's write number 1 if you are on the left side. So if to the left of you there isn't a worker, you also pick up memory 1 and you write number 0. But you don't have to pick up even. You just go away. The rightmost person needs to write 5, yeah, that's true. And the other people in the middle are gonna be looking for workers. So if to the left of you there isn't a worker, you calculate and pick up and write. Then you drop it. Don't sell high and keep going. If there is not a worker to the right of you, instead you also calculate in memory 2, bottom right -1, and pick it up and write it and drop it. Isn't a worker, I said. But you need to repeat this forever. So keep doing this, but once you've calculated something, you execute it. There. Hopefully gonna work and gonna be faster. Okay, it doesn't work. Shit. Is it because the people don't have the chance to write it just yet? So let me see. This lady. Is there a worker? No. Is there a worker? No. So calculate, and there still was a 0 there. So I would say they should step down. No. Can we tell them to step down and check for workers there? This might be way too fast even, and I don't know why I'm trying, because I think that this is no way to get 11 seconds. Oh, we could slow them down like this. So if to the left of you there isn't a worker, and there also isn't a worker to the bottom left of you. So the worker is not here, and he has finished writing the number already. And same thing here. And my hope is that this, what I've just done here, is gonna be faster than just going from the left. Now, does this work? Sorry, what the fuck happened? Why are they writing once? Did I mess up somewhere? I probably added something somewhere. This step shouldn't be here, right? Yes! Much better. And again, that was the optimization stupid thing, because I put the step there in order to make it more optimized. And it's wrong again. Shit. I just can't believe this. You know what's wrong now? Number 5 doesn't know he's counting 5s. So in memory 2, you remember you're writing 5s, you idiot. Please work. Please be fast. It works. Sometimes. But it's fast. Now, sometimes it doesn't work. Why not? Right, there are supposed to be 14 zeros. Oh, I know. Because of all the optimization I've done here, at the end, I just said... What did I say? Where is it? Oh, right. I told the first person with the zeros, she's starting here, to just start walking left. And I shouldn't have done that. Because once she jumps to here, she's basically here, and she takes top right step and up step. So she doesn't count this number here. So we do truly need to reset her. So if you are this person, you take a step to the bottom left. Now please work. Yes, it worked. Is it fast? Come on, show me. It's not 3 seconds. Come on. I've pushed myself hard and optimized this a lot. So now it's even slower than before. 4 seconds slower. Great. I didn't want them to waste any time here. You know, when going from the top, going down, they step here, and then they start going up, and these spots are basically wasted. So I make them no longer leave the grid and just stay within the boundaries. Didn't help. What might be a little faster is that the people, when calculating, slow down the people behind them. So the people behind them wait for them to move away, which is not great. So perhaps these 3 people might start going from the right side instead of from the left side. Do you think that would be a clever solution? So 3 people going from the left and 3 people going from the right. And then they bump each other in the middle, but otherwise they might, be a little faster. A little at least. We just need a couple seconds. And another thing, because my brain is already fried, how do I remove 2 commands from this? I think this should be fairly easy. Come on. They just write their numbers and they start walking. I think I might be able to get rid of 1 by combining these 2 if statements. If below you there isn't a wall and there is a data cube, actually we don't even need to say if there is a wall, because there can't be a wall and a data cube at the same time. But the data cube has to be the correct number. So get rid of the wall thing, you calculate and step. So that's 1 command off, but it doesn't work anymore. Oh, and we need to say or perhaps? Or the data cube is the same number? No, because... Oh, no. No, we can't do that. Yeah, sorry. This is just wrong. Well, anyway, how do I fix all this?